Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add the mechanic for the player to be able to cut multiple times in order to actually cut an object. Okay, so we have our cutting counter. I can drop a tomato and press a button, there you go, it cuts it straight away. Now we want the exact same logic, but we want it to take a few cuts before the cut object is spawned. So let's start off by going here onto the cutting counter, and basically let's keep track of some kind of progress. Basically, the way we do that is pretty arbitrary, it's up to you to decide. For example, you could use a normalized float. However, for cutting, since this is going to be a discrete action, let's actually count the numbers with an int. So let's store a private int, just call it cutting progress. Okay, so now let's begin by actually initializing this progress. So when the player drops something on there, let's set this one to 0. And then down here, when we have the interact alternate, we do our logic, and when we do, let's just increase this by 1. And now we need to know if the object has been cut, so we need somewhere to define some kind of maximum. And for that, we can actually do it directly on the recipe SO. So inside the cutting recipe SO, over here we've got the input, we've got the output, and let's also define an int for the cutting progress max. Okay, that's it. And back here in the editor, let's go into the tomato to tomato slices. Let's say this one takes just 3 cuts. Then for the cheese, let's also take 3 cuts. And for the cabbage, let's say it's a bit thicker, so let's say it takes 5 cuts. Okay, so back in the cutting counter here. Down here, we are adding to our cutting progress. So then we just need the recipe SO in order to grab the maximum. So let's actually go down here and actually make a different function. So this one just returns a boolean. This one a kitchen object SO. Let's make another one. This one is going to return a cutting recipe SO. So get the cutting recipe SO with input. And we're going to receive, as usual, the kitchen object SO for the input. And really going to do the exact same thing that we did up here, except instead of returning the output, let's return the recipe itself. Okay, so now that we have this more logical one, we can actually get rid of all of this copy-paste code. So over here, we just get the cutting recipe SO. And we just get it and pass in the input. So we have this one, and over here, if this one is not null, then we're going to return this one .output, and if not, we're just going to return null. Okay, so we're doing the exact same logic, just a bit simpler, okay? And up here, pretty much the same thing. So has recipe with input, let's get the cutting recipe SO, and basically just return if this one is not null. Okay, so we have our 3 nice helper functions. So let's just use this one to get the cutting recipe SO. So let's actually copy this and go up here. So we do the cutting progress. Then let's pick it up and do one for this input. So the input is going to be this one, the object currently on the cutting counter. And over here, we already know that there's going to be a recipe with this input since we've gone through this if. So then we can just check if the cutting progress is bigger or equal to the cutting recipe SO, and let's grab the maximum. If so, then yep, we do spawn it. Okay, so that's it, some very simple logic. Let's test. So here we are, let's pick up a tomato, go up there, and okay, now I'm going to press the alt to interact. Okay, press once, and yep, okay, so far so good, nothing. Now 2 times, and now if I press a 3rd time, boom, and yep, there you go, got the nice slices. Now for cheese, same thing, 1, 2, 3, yep, it works. And finally for the cabbage, this one should be 5. So 1, 2, 3, 4, and 5. And yep, there you go. Everything does work perfectly. All right, awesome. So with this, we now have progress in our cutting logic. Although, of course, just like this, it's not very good for the player. The player has no way of knowing what exactly is going on. So we need some kind of visual feedback. So for that, let's add a really nice visual progress bar. And for doing this, we're also going to learn about a really awesome Unity feature. These are world canvases. So before we make the world canvas on the cutting counter, let's actually set something up over here on the scene itself. Let's first create a regular canvas. We're only going to use this in a couple of lectures, but let's first do that one just for now. So let's go on the plus button, go into UI, and let's create a brand new canvas. Okay, so there you go. That creates a canvas and an event system. Now, like I said, we're only going to worry about this in a little bit, but for now, let's just leave those as is. And also, since we're here creating some objects, let's also take some time to organize our hierarchy. Unity sadly doesn't really have any folder objects, so you can't organize the hierarchy in any folders. However, you can use empty game objects essentially as folders. So let's make a brand new empty game object. Let's call it counters. And now, very importantly, for empty folder objects, make sure you put them on 000 so nothing breaks. So make sure you put it on there before you drag the counters. And now let's just drag all the counters inside. So all the clear counters, put them all inside. This one, also drag it inside. And all of these counters, put them all inside. So there you go, now our hierarchy is quite a bit more clean. Okay, so now let's make the cutting progress. So let's click on the cutting counter. And let's go inside our prefab, so let's go inside of it. Now over here, let's right click on the hierarchy and we're going to create a UI. Let's create another canvas. Now for this one, let's give it a name. Let's name it the progress bar UI. And for this one over here on the inspector for the settings, instead of being screen space overlay, let's make this one a world space canvas. Basically, screen space means that it would occupy the entire screen, whereas world space means that this exists in the world in whatever position it is. So let's make it world space, and over here the fields actually unlock. So let's put the positions all on 0, and for the width and height, let's also put it on 0. So basically the canvas is going to be exactly over here. By the way, the shortcut that I just used was the F in order to focus on the object. So this is useful if you're zoomed out or zoomed in way too much, okay? So we have this and we want the bar to be a little bit above, so let's actually lift it up on the Y by a little bit. So over here, let's put it on a Y of 2.5, okay. Now, like I said, the goal with this is to make a progress bar. So inside the progress bar UI, let's create a new UI image. Let's name this one our bar. Let's put it with a width of 1 and a height maybe of 0.2. So there you go, just a really thin bar. And for the color, you can play around, tint it with any color you want. Now for progress, I think maybe a blue or a yellow, something like that makes sense. So let's go with the yellow, kind of like this. Okay, so there's our really nice progress bar. And for this, let's actually use one really nice trick for making a super easy progress bar. The image component has a really easy way of making a slider image. However, it only actually works if you assign an image over here. So let's assign one in order to be able to see those options. And for that, in the included project files, there's a texture white 1x1. This is literally just a 1x1 white pixel. So here it is, just a 1x1 image, fully white. And as soon as we assign it, we do see over here the image type. So we see a bunch more options. And the one that we want is to set the sprite as filled. This one lets you do some really cool, really easy effects. For example, you can make it radial and look at what happens in there as I modify over here on the fill amount. So as I go down, look at that, it's radially filling. So for some kind of circular progress bar, this would be excellent. But in our case, what we really want is just a horizontal bar. So over here for the fill method, instead of radial, let's go with horizontal. And yep, there you go. Now by playing around this, we have a really nice progress bar. Then if you want, you can modify left to right, right to left, but yep, like this, it looks great. Now in order to modify this visual, really all we're going to need is modify over here the fill amount. This one is a normalized value, so between 0 and 1. So 0 is completely empty, 1 is completely full. However, one issue with this is when the bar is empty, then we can pretty much not see, so we can't see the actual size of the bar. We can see what size it should be. So with this, it's pretty difficult to see how far along we are. But solving that is pretty simple. We can really just add some kind of background. So let's duplicate the bar. Let's name this one the background. For this one, for the image type, we don't want anything, so let's leave it on simple. And for the color, let's put it on kind of a dark gray. Okay, great. And now here's one very, very important thing, is over here on the hierarchy, let's click and drag and place it above the bar. The reason why that is super important is because the sorting order and how it works in Unity. Basically, when it comes to UI elements inside a canvas, the sorting order is based on the order in the hierarchy. Basically, it renders from top to bottom. So the bar on top, the background, this is going to render first, and then the one below it, the bar, is going to render afterwards, which means it's going to render on top. So for the background, we want it to be behind, so place it above on the hierarchy, and that way it renders the background and then renders the bar. Also, by the way, for 2D sprites, Unity has another different sorting method. It's all based on sorting layers and sorting orders. I have a video on that topic if you're interested in 2D games. Okay, so with this, we have the background, and then we have our film bar. This way we can see if the progress is being filmed or not. Also, one more tiny thing that I like to add is Unity has some really nice, really easy to add effects. So you can go into Add Component, and let's search for a shadow. This one does exactly what you expect. It adds a nice drop shadow. Over here on the effect distance, let's put it on 0.1, 0.1 in order to see. And actually, let's not do it on this one, but do it on the background. So let's get rid of this. Instead, going to the background over here, let's add the same shadow. So if you put it on 0.1 and minus 0.1, yep, there you go, a nice simple drop shadow. Or the other one that I prefer, so instead of the shadow, let's add a really nice outline. Once again, for the effect distance, 0.1, 0.1, or maybe actually 0.05, just to be just a tiny bit. And let's raise it on the alpha, so there you go, nice little outline to our bar. This is just a visual thing, so you don't have to add this, but personally I find that it looks pretty good. So with all of this, we have our visual perfectly set up. We've got our nice bar. All we need to do is play around the fill amount in order to fill it. So now all we need to do is to connect this to the logic. But as usual, let's make sure to write some good clean code. So we do not want the cutting counter to directly touch on this image. Instead, let's make a script to handle that. So let's right click, create a new C# script, call it the progress bar UI. And just personally as a rule, I like to append the UI to any UI script. You don't have to do that, it's just a rule that I personally find helpful to follow. That way, just by looking at the scripts, I can immediately see this one is a UI, this one is script and logic, and so on. So on the progress bar UI, on the main game object, let's attach the script and let's open it. Okay, so now here we're going to need a reference to our image. So let's add a serialized field, private, and we're going to need the image type. And now importantly, this is inside using Unity Engine.ui. So let's go up here using Unity Engine.ui. So we have our image component. Okay, great. Let's call it the bar image. So we have our reference. And now with this, obviously, we need to have some kind of reference to the counter so we know when the progress changes. So it's really the same thing that we've already done so many times throughout this course. So let's add a field up here, serialized field, private cutting counter for our cutting counter. Then over here in the editor, let's drag the references. So drag the reference to the cutting counter and another one to the bar image. Okay, great. Now we just need some kind of event to update the bar image. So let's go over here into our cutting counter script. Let's make an event to spawn that. So public event, let's use the event handler, the default standard. Let's call it on progress changed. And let's also make a nice event args to be able to send the current progress amount. So let's make a public class on progress changed event args, and let's extend event args. And then inside it, let's put the current progress. However, let's also pass in the progress as normalized, since that's what the bar will use. So public float, progress normalized, and we're going to make this event of this type. Okay, great, so we have our event. Now whenever we modify the progress, we just need to fire this event. So over here, when resetting the progress, let's fire it. So let's invoke, pass in this, instantiate our event args, and pass in the progress normalized. And to get the normalized progress, it's actually very simple. Basically, we just need to divide the current progress by the maximum. So cutting progress divided by cutting progress max, which is actually inside the recipe SO, so we need to pick that one up. So let's go down there to pick up the cutting progress recipe. So we pick this one up and we go in there and get the maximum. However, over here we also need to be very careful because there's one sneaky issue here. This has to do with how C# works and how ints are divided with other ints. For example, if we had a cutting progress of 1 and cutting progress max of 5, you would think 1 divided by 5 would equal 0.2. However, if we actually did that, over here we would actually get a 0. And the reason for that is because we are dividing two ints. Cutting progress is an int, cutting progress max is also an int. And if you divide an int by an int, then the end result will also be an int. Since you cannot define 0.2 in an int, the decimal gets cut down and you end up with just 0. So that would not be correct. In order to get the right value from this calculation, we need to make sure to convert one of these values onto a float. So that's really simple, we just cast one of them, so just cast this one to the float, just like that. Basically now this one will first be cast to a float, and then we're going to have a float divided by an int, and the end result will be a float. So if you ever do some math and you get some weird results, always make sure to check the type of your numbers. Okay, so here we are correctly firing the event, and then down here when adding our progress, let's do the same thing. Let's also fire on the event. So now we can go back into our progress bar UI, and over here let's listen to the event. And again, remember that if we're accessing an external reference, let's do that on start and not on awake. So cutting counter, listen to the on progress changed event. When that happens, let's just go bar image and set the fill amount to what we receive from the event, so the progress normalized. Okay, so that's really it. And also up here on start, let's initialize it as 0f, so the bar is nice and empty. Okay, so let's test. Back in the editor, let's just go back into the scenes, make sure the prefab has been saved, and let's hit on play. And right away, yep, we do see the bar. Yep, it is empty. Now pick up some cheese, drop it, and if I cut, and yep, there you go, added a little bit of progress, now a bit more, and there you go, there's our cheese. Okay, great, everything does work. Now let's add just one more tiny bonus thing. We can add some extra logic in order to hide this visual if the bar is either completely empty or completely full. That is actually pretty simple. Over here on the progress bar UI script, let's just make some basic show and hide functions. So private void show, and then we're going to have a private void hide. On these ones, just game object set active, this one set it to true, and this one set it to false. Now on start, we subscribe to the event, and then let's hide it, okay? Also here, it's very important, make sure you hide it after you listen to the event. If, for example, you called hide on awake, that would disable the game object and the start would never run, so it would never listen to the event. So if you ever set the game object as inactive, make sure you do it only after you're listening to whatever events you want. So we have this, that's great, and then when the progress changes, let's just do a basic test. So if e.progressNormalized equals 0f, or if the progress normalized equals 1f, so if the bar is completely empty or completely full. If so, then let's hide it, and if not, then let's show it. Okay, that's it, let's test. Okay, and yep, by default starts off hidden. Let's pick up a tomato, go up there, and yep, still hidden. Now I cut, and there you go, there it is, cut again, and yep, there you go, it hides itself. Okay, great, so we've got a nice little visual. Let's do just one more final thing. Let's add a really nice animation. If we go inside the cutting counter, and we'll look at the cutting counter visual, over here, note how it already has an animator. Just like we did for the container counter, it's all very simple. So basically just has a cut parameter. When that happens, it just cuts the counter. So it just plays a simple animation. Since it's going to be pretty much exactly like the container counter, let's actually duplicate that script. So let's go down, find that script. So the container counter visual, let's duplicate this. So Control D. Let's rename this to the cutting counter visual. Okay, let's open. And over here, let's rename the script. So the cutting counter visual. Okay, great. Then for the parameter, let's rename this. Instead of open close, it's going to be called cut. And for the string, it's cut. Again, make sure you write it case sensitive. Make sure it's all correct. Then instead of having a container counter, we've got a cutting counter and a cutting counter. And finally, we just need to listen to the correct event. So technically, we could listen to the onProgress changed. However, that one also gets fired over here when the cutting progress is 0. We don't want the cut animation to play when this happens. So let's just make another simple event. So a public event handler. Let's call this just onCut. Okay, and then down here when we have our cutting progress, so we cut and let's just invoke this event. Okay, that's it, super simple. So now on the cutting counter visual, let's go into the cutting counter and into the onCut event. Let's listen to this, and we're going to set the trigger exactly like this. So get rid of the container counter like this. Okay, there you go, a very simple script. So now here back in the scene view, inside the container counter prefab, let's just go inside the visual. Let's attach the cutting counter visual. Just need to drag the cutting counter reference, and that's it. Let's exit the prefab, save it, and let's play. Okay, so now let's pick up a cabbage, go up there, drop it, and Alt Interact. And if there you go, we've got a nice little animation. All right, awesome. So I can drop things, I can cut them, and everything works perfectly. All right. So here we added a cutting progress to our cutting counter, and we also learned about yet another very useful Unity feature called World Canvases. And at the same time, you might have also noticed that the canvas is looking at the camera in kind of a weird way, basically just pointing straight forward. This can sometimes make it difficult to see, so let's work on that in the next lecture.